Hi, my name is Ali Shersawal from Bridge Digital, and in this short video we're going to talk about common mode chokes operation and why you have got certain amount of differential mode inductance within a common mode choke. First, let's have a look at the operation of a common mode choke. The choke itself looks something like this. You can see that you have got two windings. So there's one winding that goes on this side and you've got another winding that goes on this side. It's effectively a transformer with identical number of windings and the dots being both on the same side. So if I draw the two windings on this board, I've got one winding on this side and one winding on the other side. In practice, this would look something like with the dot notation suggesting that the directions are both in one way. Let's see what happens to common mode currents. In one of the previous videos, we said that the common mode currents go in the same direction and then return through the parasitic capacitances via the chassis. Now, if I assume that I have got some common mode current going through the line and through the return, both in the same direction, I've put an arrow on. I'm not sure if you can see it or not. Let's say that is the direction of this one, and that's the direction of that one. From school level physics, we remember the corkscrew rule, whereby it determined the direction of the flux line. So if I put my thumb towards the direction of this, I can then show that you have got flux lines going that way and that way, and that way and that way, and so on. The total net flux, therefore, for this, as a result of this current going through this coil, is that way. Yeah? Now, let's have a look at the other winding. We know that because there are common mode currents, they're going in the same direction. So the return current is going in this direction. Again, I use the corkscrew rule, and I can see that the direction of the flux lines is like so and like so, like so and like so, and therefore the total net flux is this way. And you can see that these two add to each other as a result, and therefore to common mode currents, any currents that goes in that direction, this looks like a huge choke, which is exactly what we want. We want to have massive amounts of inductance because we are going to use it as a filter. Now, let's take the same choke and look at what happens if the direction of the currents are reversed, in that we have got differential mode currents. Now, on a differential mode current, I have got current going this way, but the return current is coming in the opposite direction. Now, if I draw the flux lines again using corkscrew rule, you can see that this one stays exactly the same as that. So I have got this, which is going to give me some flux this way. Yeah? But now the direction of the current on this one has reversed. And if I do the same thing now and draw the flux lines, you'll see that it's going like so. And when I do the resultant, actually the resultant flux is that way. So to differential mode currents, the flux that is being generated down this coil is actually opposing the other one, and they cancel each other out. And therefore, to differential mode current, this choke looks invisible, whilst to common mode current looks like an enormous choke, which is exactly what we want. Now, in an ideal world, 100% of the flux would couple, and therefore you would have zero differential mode inductance and lots of common mode inductance. In reality, this never happens because some of the flux leaks. And when this flux leaks, and this is called the leakage inductance or stray inductance, and some manufacturers even call it differential mode inductance, the name gives it away, not all of the differential mode currents cancel. And therefore, in every common mode choke, you have got certain amount of leakage, and that manifests itself as a differential mode inductance that we use in filters like we draw in one of the previous designs the stray inductance of this common mode choke is right here and is being used to filter out, I beg your pardon, the differential mode component of this common mode choke is being used to filter out the differential mode currents. We can make a measurement with the body 100 in order to show that there is a certain amount of leakage and that acts like a differential mode choke.